Hello everyone. On this video we will be looking at inverse trig functions. Okay, so first we're going to take a quick look at the graph of the inverse trig functions. And if you remember, for a regular function it's 1-to-1 if it passes the horizontal line test. Okay, so let's look at the little sketch of sine of x. Okay, so we see here the entire graph would fail the horizontal line test. So what we're going to do is we're just going to take a chunk of it between negative pi over 2 and pi over 2. So if you notice, if you take just that chunk of it and just kind of cover up everything else, it passes the horizontal line test. Okay, so just between that, we're going to get that one and we're going to kind of rotate it. And when we rotate it, instead of our domain being from negative pi over 2 to pi over 2, and our range being from negative 1 to 1, we have our domain from negative 1 to 1, and our range from negative pi over 2 to pi over 2. Okay, so this is the graph of sine inverse of x. Okay, same thing with cosine and cosine inverse. Notice your cosine of x. Remember, if you go from 0 and you go all the way down here, if you turn back up, it would fail the horizontal line test. So we're going to go from 0 just to pi, and we're going to stop there. Okay, so if we get that graph, remember if we rotate it to where now our y-axis is horizontal and our x values are vertical, instead of having our range being from negative 1 to 1, now our domain is from negative 1 to 1. Okay, and we're still going from 0 to pi for our range. All right, so if you're still writing this, feel free to pause it, but we're going to go ahead and move on to our tangent graph. Okay, so this is our tangent graph. And again, we can't do the whole thing because it would fail the horizontal line test. So we're just going to take the chunk from negative pi over 2 to pi over 2. Okay, so if we ignore everything else, this is just that chunk that we rotate. So instead of our range being from negative infinity to infinity and our domain being from negative pi over 2 to pi over 2, now the range is negative pi over 2 to pi over 2. And the domain is from negative infinity to positive infinity. Okay, so everything is just kind of twisted around with our range and domain of our inverse tangent function or our inverse trig functions. Okay, so again, if you're still writing this, of course, feel free to press pause and finish up. But we're going to go ahead and start on a few problems involving our inverse functions. Okay, so what if we wanted to evaluate and express as a simplified fraction? Okay, so what if we have sine inverse of square root of 3 over 2, arc cosine of negative 1, and if we had arc tangent of square root of 3. Now, sine inverse and arc sine mean the same thing. Arc cosine and cosine inverse means the same thing. Arc tangent and tangent inverse, same thing, just different notation. All right, so first thing we're going to do with A, we're just going to make sine inverse of square root of 3 over 2 equals some value y. Okay, now once we do that, we're going to apply sine to both sides. All right, so that would give us sine of sine inverse of square root of 3 over 2 equals sine of y. Okay, so we applied sine to both sides. Now the sine and the sine inverse will cancel each other out. So you have sine of y equals square root of 3 over 2. Okay. Now, one thing we have to remember is that for sine inverse, the range of sine inverse is negative pi over 2 to pi over 2. Okay. That means our angle has to fall in that inverse. In that interval. Okay. So quick note. Okay. So different values or different angles can equal our square root of 3 over 2. So if you notice, both sine of pi over 3 and sine of 2 pi over 3 equals square root of 3 over 2. But only pi over 3 is in the range of negative pi over 2 to pi over 2. Okay, so even though multiple values of y can make that true, only one will be within that range. Okay, so we know that if sine of y equals square root of 3 over 2, that's when y is equal to pi over 3. All right, so let's go ahead with B. Let me move that up a little. What if we have arc cosine of negative 1, and we make that equal some y? Okay, so we're going to do the same thing we did up here, and just apply cosine to both sides. Okay, so that will give us cosine of arc cosine of negative 1 equals cosine of y. Okay, and remember, arc cosine and cosine inverse, same thing, just different notation. So those two cancel each other out. So you have cosine of y equals negative 1. Okay. Now, different values of y would make this true, but we have to remember that the cosine inverse range is from 0 to pi. Okay, and these are closed circles, so we can include pi. Okay, so we know that cosine of pi and cosine of negative pi both equal 0. Equal negative 1. But cosine of pi is within the range. Okay, that's the key there. Yep, equals negative 1. Okay, so if cosine of y equals negative 1, that's only when y is equal to pi. Okay, so let's go ahead and do C. If we have arctangent of square root of 3, we just make that equal to some value y. Okay, so on this one, of course, we apply tangent inverse to both sides. Okay, so that means we have, oh, not tangent inverse, just tangent. Sorry about that. because we have the arctangent, which is already our tangent inverse. So we have tangent of arctangent square root of 3 equals tangent of y. Okay, so remember the arctangent and tangent cancels out. So you have the tangent of y is equal to square root of 3. Okay, now what do we have to remember? Well, we have to remember the range of our tangent inverse. Now that's negative pi over 2 to pi over 2, but it's an open interval, which means you can't include negative pi over 2 or pi over 2. Remember, your tangent graph has vertical asymptotes at those points. Okay. Now again, we're going to note that tangent pi over 3 and tangent 4 pi over 3 both equal square root of 3, but only the pi over 3 is within that range. But pi over 3 is within range. Okay, so we know that tangent of y equals square root of 3 when y is equal to pi over 3. Okay. Excuse me. Okay, so it's not too horrible. Okay, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Bring this down. Okay, so what if we wanted to evaluate cosine of sine inverse of negative 12 over 37? Okay, so we have kind of a composite function with our trig functions. Okay, so how do we solve these composite trig functions? Well, we kind of start from the inside out. Okay, so let's go ahead and do that. So let's say if we have cosine of sine inverse of negative 12 over 37. Okay, so what if we let theta equal our sine inverse function? Oops, put my 7 on the outside there when I should have put it in the denominator. There we go. Okay, so if we apply sine to both sides, then that means that sine of theta is equal to, if we apply sine over here, the sine and the sine inverse would cancel out. So sine of theta equals negative 12 over 37. Okay, so we know that sine is only negative in the third and the fourth quadrant. So we did like a little sketch. Okay, so in quadrant 1, everything is positive. In quadrant 2, only cosine and secant are positive. In quadrant 3, we have cosine is negative, sine is negative. In quadrant 4, cosine is positive, sine is negative. Okay, so if we start on our initial line and go this way, this is positive pi over 2. But if we're going the negative direction this way, then this would be our negative pi over 2. Okay, so we see here that since our interval is between negative pi over 2 and pi over 2, it has to be either quadrant 1 or quadrant 4. And since it's only negative in quadrant 4, we know that this has to be in quadrant 4. Okay, so we know that it's in that corner. So what we're going to do is going to draw just a little XY axis with our right triangle in quadrant 4. Okay, and this is our angle theta. And remember, sine is also opposite over hypotenuse. So if this is our angle, this is our opposite, the negative 12, and our hypotenuse is your 37. Okay, so since we have a right triangle, we can use the Pythagorean theorem to solve for our x. So we have x squared plus y squared. It's a unit circle, so we know our radius is equal to 1. So we know that our y is negative 12. So we have x squared plus negative 12 over 37 squared is equal to 1. Because remember, that's our sine of theta. Okay, and if you remember on a unit circle, sine of theta is equal to y over the radius, and the radius is 1, so it's just equal to y. So we replace that with our y squared. Okay, so if we square this, we get positive 144 over 1,369 for our 37 squared. So if we subtract that from both sides, we get x squared equals 1 minus our 12 squared, which is 144, over 1,369. Okay, so if we solve this and square root both sides, we get x is equal to 35 over 37. Okay, now remember, your cosine theta is equal to x, which is equal to 35 over 37, which is also your adjacent of hypotenuse. So we see that our adjacent is 35. Okay, so we know just from where we started off, let me move this up a little bit, cosine sine inverse of negative 12 over 37. Remember, we made this equal to our theta. So cosine of theta is equal to 35 over 37. Okay, so that's the solution to our cosine of sine inverse of negative 12 over 37. All right, so if you are still writing, feel free to press pause and finish up. We're going to go ahead and move on to our next examples, which explains the inverse of secant, cosecant, and cotangent. Okay, so just like with our sine, cosine, and tangent, again, we can't do the entire interval or the entire graph with the horizontal line test because it would fail, so it wouldn't be 1 to 1. So what we're going to do is we're going to go just from negative pi over 2 to pi over 2. Okay, so if we cut all of that out and we have just negative pi over 2 to pi over 2, just kind of getting from negative pi to pi, just to kind of show you the whole thing. From negative pi over 2 to pi over 2, this part that's filled in. Okay, so I took the entire graph and just kind of dotted half of it, but we're only counting between pi over 2 and negative pi over 2. So if we remove the little dotted section, this is your graph of cosecant inverse. Okay, where your domain is x is less than or equal to negative 1 or greater than positive 1, and your range is between negative pi over 2 and pi over 2. All right. So if you're still writing, feel free to pause it, but we're going to go ahead and move on to the next page. Excuse me. So if you look at secant, again, this is our secant graph. And again, what we're going to do is, because secant is just the reciprocal of cosine, again, we're going to go from 0 to pi just like with cosine. So we're not going to switch up which chunk of the graph we're going to use. Okay, so if we go just from 0 to pi, so from here to here, move that away, there we go. So we can kind of see here how that would look out. So if we turn it sideways to where this is our pi over 2 and this is our 0 here, you can see the graph will look something like this. Again, we chopped off the second half of that part of the graph, and just from 0 to pi to where our domain is x, then x is less than or equal to negative 1, or x is greater than 1, which is our domain values here, and our range is from 0 to pi, but y cannot equal pi over 2. Remember, that's one of our vertical asymptotes here. So once we rotate it for our inverse function, it becomes a horizontal asymptote. So we still can have y equal pi over 2 in this case, where in our secant we couldn't have x equal pi over 2. Okay, and last but not least, we move up to our cotangent. Again, this is just a quick sketch of our cotangent. Okay, so what we're going to do is we're just going to take from 0 to pi. Okay, so we're going to get that graph and move it over here. So from 0 to pi, this is the portion of we're using for our inverse. So we're just getting that graph and turning it sideways. Okay, to where now our domain is from negative infinity to infinity, and our range is from 0 to pi. Okay, so as long as you remember the range of each one of your trig functions, you should be okay. That's the important part. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our next page. Okay, so let's evaluate arc cotangent of negative square root of 3 over 3 and cosecant inverse of 1. Okay, so we're just going to rewrite that as arc cotangent of negative square root of 3 over 3 equals some variable y. Okay, so of course we're going to apply cotangent to both sides. So if we have cotangent of arc cotangent of negative square root of 3 over 3 equals cotangent of y, remember the arc cotangent and cotangent cancels each other out. It's just like cotangent and cotangent inverse. So we have cotangent of y is equal to negative square root of 3. Okay. Now remember that the inverse of cotangent is from 0 to pi. Well, cotangent inverse is from 0 to pi. Okay. Now remember, quick note, that cotangent 2 pi over 3 and cotangent negative pi over 3 both equal negative square root of 3 over 3. But only one of them falls within that range. But only 2 pi over 3 is within range. Of 0 pi. Okay, so what does that tell us? Well, that tells us that cotangent of y equals negative square root of 3 over 3. When y is equal to 2 pi over 3. Okay, so that kind of helps a little bit. Okay, so let's go ahead and do B. Okay, so cosecant inverse of 1 will make that equal to y. Okay, so again, we're going to apply cosecant to both sides. Cosecant of cosecant inverse of 1 equals cosecant of y. Okay, so again, we know that those two cancel each other out. Okay, but we have to remember cosecant inverse range is negative pi over 2 to 0, or from 0 to pi over 2. Okay, so it doesn't equal 0. It can equal between negative pi over 2 and pi over 2, but y can't equal 0. Okay, well, we do have to note something, that cosecant of pi over 2 and cosecant of 5 pi over 2 both equal 1. Okay, but as you probably guessed, only one of them fall within the range. But the 5 pi over 2 is the only one, the pi over 2 is the only one within range. Okay, so we know that cosecant of y equals 1 when y is equal to pi over 2. All right, so let's go ahead and do one more example. And again, if you're still writing, feel free to press pause and finish up. We're going to go ahead and move on to our last example. Okay, so what if we wanted to evaluate sine inverse of tangent of pi over 4 and tangent inverse of cosine of negative 3 pi over 2? Okay, so let's start with A. Okay, so the first thing you want to remember that the range of sine inverse is negative pi over 2 to pi over 2. Okay, so that means that solving from the inside out, we know that tangent of pi over 4 is equal to 1. Okay, so that means that sine inverse of tangent of pi over 4 equals y will become sine inverse of 1 equals y. Okay, so again, we apply sine to both sides. So it gives us sine of y is equal to 1. And that's when y is equal to pi over 2. Okay, so let's go ahead and work out problem B. We have tangent inverse cosine of negative 3 pi over 2. And of course, our tangent inverse range is negative pi over 2 to pi over 2. Okay, so if we solve just the inside, we know that cosine of negative 3 pi over 2 is equal to 0. Okay, so that means our tangent inverse of cosine of negative 3 pi over 2 equals y. As we know that this is equal to 0, that's just tangent inverse of 0 is equal to y. Which means that if we apply tangent to both sides, tangent of y is equal to 0 when y is equal to 0. Because 0 is within our interval. So we're good to go there. All right. So hopefully this made sense, and I will see you on the next video.